Good evening, children.
Good evening,
Good
ma'am.
evening, ma'am. Good evening. Yeah, I was just waiting for the others to join, but not much response, so we'll begin the session. Yeah, this is the first question. Factorize using factor theorem. Those who know can start working. For the others, I'm explaining. So the given polynomial is a cubic polynomial. You can see that the highest power of x is 3. So it's a cubic polynomial. X cubed minus 23x squared plus 142x minus 120 is a cubic polynomial. The highest power of x is 3. The power of x is 1 here, 2 here, 3 here. The highest power is 3, and so the degree of the polynomial is 3. The given polynomial is a cubic polynomial. Now we need to factorize using factor theorem. Factorize meaning we know that a cubic polynomial can have a maximum of 3 factors. A cubic polynomial can have a maximum of 3 factors. We need to factorize this cubic polynomial, meaning find its 3 factors. So see here, at the end of the answer, we found the 3 factors. X minus 1, x minus 10, and x minus 12 are the 3 factors of this given cubic polynomial. So factorize meaning find the factors of the polynomial. Like when we have to factorize, say 15, we write 15 as 3 into 5 as a product of its prime factors. Factorize 15. 15 is equal to 3 into 5 or 5 into 3. So we write 15 as a product of prime factors. Similarly, here we'll have to write the given cubic polynomial as a product of its linear factors. As a product of its linear factors. Sometimes you can get one quadratic factor and one linear factor. You can get one quadratic factor and one linear factor. So that depends on the cubic polynomial. So now how do we do this? So let's name this cubic polynomial given. So let f of x be the given cubic polynomial. Let's name it. Now let's try f of 1. Let's try f of 1. That is, in the polynomial, in place of x, we're going to use 1. And find the value of the polynomial at x is equal to 1. Find f of 1 meaning find the value of f of x at x is equal to 1. So when you work f of 1 is 0. F of 1 is 0. That means when you take 1, x is equal to 1, right? So when you take 1 to the other side, you'll get x minus 1. What have you taken as the value of x? 1. X is equal to 1. X is equal to 1. So when you take this 1 to the other side, it will be x minus 1. So x minus 1 is a factor of f of x. When can you come to this conclusion? Only when the value is 0. Now, supposing you don't get 0. F of 1 is not 0. You get something else other than 0. Then you'll have to try a different value for x. You should try f of minus 1. Now, supposing this is not 0, you get some other value. Then you try f of minus 1. Now, if that is 0, if f of minus 1 is 0, that is x is minus 1, right? X is equal to minus 1. So when you take the minus 1 to the other side, you get x plus 1. That means x plus 1 is a factor of f of x. Now, supposing f of minus 1 is also not 0, then try f of 2. Go ahead, f of minus 2, 3, minus 3, go on like that till you get 0 as the value. So supposing f of minus 2 is 0. So x is equal to minus 2 because in place of x, you've used minus 2. X is equal to minus 2. So when you take this side, you'll get x plus 2. So x plus 2 is a factor of f of x. So this is how we work. Now, since here, in the first shot, f of 1 is 0. We conclude that x minus 1 is a factor of f of x. Now, for a cubic polynomial, to factorize a cubic polynomial, it is enough if you find one linear factor. To factorize a cubic polynomial, it is enough if you find one linear factor. Now, after finding that one linear factor, take up the given cubic polynomial and divide by the linear factor, x minus 1. Perform the long division. So how do we perform the long division? Again, for those who are not completely clear about the long division, you can listen now. So take up the first term, x cubed, divide by the first term of the divisor, x. So that gives us x square. x squared. That will be the first term in the quotient. That will be the first term. See, how do you start the long division? What do you have when you start the long division? You only have the dividend x cubed minus 23x squared plus 142x minus 120. You have this and you have x minus 1. You have nothing else. You have nothing else. So now you're going to start the division process. X cubed divided by x is x squared. Okay, x squared. So write x squared. Now multiply x squared with x, multiply x squared with minus 1. X squared into x. X squared into x is x cubed. X squared into minus 1 is minus x squared. Multiply x squared with x and minus 1 and write the result here. Then change the signs because we'll have to subtract, change the signs. Change the signs. So plus becomes minus, minus becomes plus. Change the signs, take the new signs, take the new signs. So it's plus x cubed and minus x cubed. Take the new signs. Plus x cubed minus x cubed, 0. Minus 23x squared and plus x squared. Take the new sign, forget the original sign. Minus 23x squared plus x squared. Minus 22x squared. You can bring the remaining two terms down or you can just bring the next term down, anything. You can bring this minus 120 also down if you want. Okay, so bring the next term down or as I told you, you can also bring this down. Now again start the division, the second stage. Now to find the second term in the quotient, again divide this minus 22x squared by x. Divide the first term here by the first term here. This is the new dividend. This remainder is called the new dividend. This is the new dividend. So always we divide the first term of the dividend by the first term of the divisor. That's what we always do. The first term of the dividend by the first term of the divisor. Divide. Minus 22x squared by x. So and that is minus 22x. And that will be the second term in the quotient. That will be the second term in the quotient. Now what do we do? As we did earlier, multiply minus 22x with x minus 1. Minus 22x with x first. So minus 22x squared. Then minus 22x with minus 1. Multiply. So plus 22x. When you multiply, you get plus 22x. Multiply minus 22x with x, you get minus 22x squared. And minus 22x with minus 1, you get minus 22x and minus 1. You get plus 22x. Change the signs. Gets cancelled. And on simplifying this, you get 120x. Then this term down, minus 120. Again, to find the third term in the quotient, divide. This is the new dividend now. This is the new dividend. So divide 120x by x. You get 120, meaning plus 120. Plus 120. That's the third term in the quotient. That's the third term in the quotient. And again, multiply 120 with x. 120x. Multiply 120 with minus 1. Minus 120. 120 into minus 1. When you multiply, you get minus 120. Change the signs. Change the signs. Minus, plus, change the signs. You can do it here itself. I told you. You don't. When I type, I have to put it down here. I can't write it. I can't show it here. So you can show it here in the bracket. I told you in one class earlier, you can show it here in the bracket. So yeah, they get cancelled and 0. The remainder must be 0 because you're dividing the cubic polynomial by its factor. So the remainder should be 0. Now use the division algorithm. Use the division algorithm. By the division algorithm, we know that the dividend, this dividend is equal to divisor into quotient plus remainder. This is the division algorithm. Dividend is equal to divisor into quotient plus remainder. So what is the dividend? This one, this cubic polynomial is a dividend and we've called it f of x. They've called it f of x. So I'm writing the dividend as f of x is equal to divisor. This is the divisor into quotient, divisor into quotient. This is the divisor into quotient. This is the quotient into quotient plus the remainder. Remainder is 0. So plus 0. So you don't have to show it. The remainder is 0. So you don't have to show plus 0. Divisor into quotient plus the remainder. But since the remainder is 0, you don't have to show that plus 0. So by the rule, by the division algorithm, we write this equation. F of x is equal to, that is the dividend, is equal to divisor into quotient. Now, this is already linear. Factorize this by splitting the middle term. Factorize this one by splitting the middle term. So that you know the sum is minus 22. The sum is minus 22 and the product is 120. So you'll have to find the two numbers that satisfies the sum and the product. And the two numbers are minus 12 and minus 10. The product is 120 plus 120 and the sum is minus 22. So you know that procedure. Split the middle term and group this, group this. The rest of it, you know. So x minus 1, x minus 10 and x minus 12 are the three factors. We factorized. See, we found the factors finally. X minus 1 is one factor, x minus 10 is the other factor, and the third factor is x minus 12. Any order you can write. You can write it in any order. The order is not important. You can write x minus 12 first and then x minus 10 and then x minus 1. The order is not important. 15 is 3 into 5 or 5 into 3. Order is not important. The factors are important. So this is the procedure to factorize a cubic polynomial using factor theorem. Yeah, finish it. Class, use the emoji. Raise your hand. Netra, Sindhu, Sanjay, Krishmika, Tanishka, Prajit, Arjun, Srijana, and Lishant. Okay. 1 minute, children. Done, children?
No.
Yeah. You students, Srijana and Lishant, any questions? Srijana?
No, ma'am. No, ma'am.
Okay. This changed sign, you can write it here itself. Please write it here. Put a bracket and change the sign here like this. Don't put it down here.
Ma'am?
Yeah.
Ma'am, in the last step, x minus 1 into x minus 12 we have written, no, ma'am. For that, we can write 1 also, ma'am, in x, in spite of x.
Instead of x,
Yes.
is it Krishmika, Shri?
Yes, ma'am.
Yeah, your question is about this one?
Yes, ma'am.
Okay. Okay. So you're talking about x square minus 12x minus 10x plus 120. Yes, tell me. We are grouping these two, right?
Yes, ma'am.
What is common between x square and x?
X, ma'am.
X. Open bracket. X into what will give you x square?
X.
X into x is x square, right? So we cannot write 1 there.
Okay, ma'am.
X into x is x square. Then x into what will give you minus 12x?
Minus 12.
minus 12. Then this minus, bring it down as it is, this minus. What's common between 10x and 120?
10.
10. Open a bracket. 10 into what will give you this third term, minus 10x.
X.
X, because minus 10 into x is minus 10x. Now the fourth term is plus 120. Minus into minus is plus. Minus is here outside. Minus into minus is plus. And 10 into what is 120? 10 into 12 is 120.
Okay, ma'am.
Yeah, so you cannot write 1 here. Very good. Any other doubt? Krishmika Shri or others, any doubt? Yes, this is what I want children to do. Please ask, see, all of us will have different kinds of doubts. I'm explaining in general, but you will have something specific to understand better. You should ask me. Very good, Krishmika Shri. Any other question?
No, ma'am.
Okay. All right, we'll go to the next one. So factorize this, very good. You turned on your camera after a long time, Krishmika Shri. Very good. Yeah. So yeah, factorize this biquadratic polynomial. So because you can see the highest power of x is 4. So this one is a biquadratic polynomial. Again, you need to factorize this using factor theorem. So for a biquadratic polynomial, you will have to find 2 factors. For a remember that for a biquadratic polynomial, you'll have to find 2 factors. Should find 1 linear factor and 1 more linear factor. For a cubic polynomial, you can just find 1 linear factor and then perform the long division. See, the procedure is this. First, you should find for a cubic polynomial. First, you should find 1 factor. First 1 factor, then the division process, then splitting the middle term. First, you should find 1 factor, then you should divide, division process, then splitting the middle term. Use a division algorithm and split the middle term and find the remaining factors. Same thing here also for a biquadratic polynomial, but just that you should find 2 factors, x minus 1, x plus 1. Should find 2 linear factors. Should find 2 linear factors. Then multiply these 2 linear factors, multiply this and find the quadratic factor. You should divide this one by this quadratic factor. And then use the division algorithm, split the middle term and find all the factors. So 2 linear factors, multiplying the 2 linear factors, getting the quadratic factor, then the long division. Divide the biquadratic polynomial by the quadratic factor. The remainder will be 0 because you're dividing by a factor. The remainder will be 0. And then use the division algorithm. Split the middle term and find all the factors. So as I told you earlier, find P of 1. If it's not, see, we found P of 1 and we are happy with it because we're getting the value as 0. So that means x minus 1 is a factor. When you find P of minus 1, we are getting 0. That means x plus 1 is a factor. So supposing P of minus 1 was not 0, then you should find P of 2. That's also not 0. Find P of minus 2. That's also not 0. Find P of 3. So mostly you will get when you work 1 minus 1, 2 minus 2, 3 minus 3. Within this, you will get your value mostly. That's how the polynomial will be designed for you. So it's not that you'll have to work up to or 10 or 20. So don't worry. So one of these numbers will work. One of these numbers will work. Okay, so here we get P of 1 is 0. That means, as I told you, x is equal to 1. So x minus 1 is a factor. Here x is equal to minus 1. Because in place of x, you're using minus 1. X is equal to minus 1. So x plus 1 is a factor. X plus 1 is a factor. So find 2 factors, multiply the 2 factors. Now this is of the form a plus b into a minus b. See, it need not always be like that. Listen to me carefully. Listen to this, all of you. Supposing you got x minus 1 as a factor and then x minus 2 as a factor. Supposing. See, here you've got x minus 1 and x plus 1. So how do you multiply? It's like a minus b into a plus b. X minus 1 into x plus 1 is like a minus b into a plus b. So the product is a square minus b square. X square minus 1 square, which is 1. You can do the regular multiplication also. I'll tell you, I'll just come to that. Now, supposing you have x minus 1 into x minus 2, how to multiply this? It's not a minus b into a plus b here. So do this multiplication, x into the second bracket, x minus 2. See, what am I trying to explain? I'm trying to tell you how to multiply if the factors were x minus 1 and x minus 2, where you cannot use the identity a minus b into a plus b. If the factors are x minus 1 and x minus 2, how do we multiply them? 8th standard, first term into the second bracket, minus 1, the second term into the second bracket. This is how you multiply. So x into x, x square, x into minus 2, minus 2x, minus 1 into x, minus 1 into minus 2, plus 2. And then x square minus 3x, minus 2x minus x is minus 3x. Like terms, you can simplify them, plus 2. So this is the product. This is the product. Now here we have got x square minus 1, right? So in this case, you will get x square minus 3x plus 2. Now, I'm also going to tell you, supposing you didn't know that you had to use identity. Okay, so you do the regular multiplication. Then also you will get the same answer. Supposing instead of using the identity, you do the regular method. X into the second bracket, minus 1 into the second bracket. Okay, the answer will not be different. Tell me, what is the product? How do we multiply? Tell me. Yeah. Yeah.
X
Minus x minus 1. Now what will get cancelled? So what is the result? That's what you get using the identity. So what happens when you use the identity? You're saving little time. When you use the identity, you're saving little time. It's not that you will get a different answer using the identity, and if you do the regular multiplication, you're going to get a completely different answer. It cannot be like that. It cannot be like that. So even if you forget that you can use an identity and do the regular multiplication, you should still get the same answer which you would get using the identity. So the same thing you will get. Just that you'll take some 30 seconds extra. That's all. No, I don't know if you should tell me if all of you understood what I was trying to explain. Children?
Yes, ma'am.
All of you?
Yes, ma'am.
Yeah.
So this is how you multiply when you have two factors. Oh, sorry. When this is how you multiply when you cannot use any identity. First term, second bracket, second term, second bracket. Now, after getting the quadratic factor, perform the long division. Perform the long division. Do the long division, and then we'll do the long division again. For those who still need to understand better, I'll work the long division for you. Now, after performing the long division, the division algorithm, dividend. This is the dividend P of x. We have called it P of x. They have called it P of x. Dividend P of x is equal to divisor into quotient plus the remainder. Remainder is 0. So you just leave it. Now x square minus 1, you should factorize. What are the factors? X plus 1 and x minus 1. So you don't have to again do the procedure. You can straight away x square minus 1, when you factorize it is x plus 1 into x minus 1. When you multiply them, you got x square minus 1. So the factors of x square minus 1 are x plus 1 and x minus 1. Then how do you factorize this? By splitting the middle term, And here are the 4 factors. Yes, please complete this, children. Yes, Srijana, tell me how to perform the long division. Just tell me the, oh, I have it here, okay. Others can do it, you know how to work it. Srijana. Rishmi. Who wants to do the long division? Who wants to help me to work the long division?
No, I can.
No, but okay. Rajat?
Yes, ma'am.
Yeah, tell me.
And first you gotta divide x to the power 4 by x to the power 2, ma'am.
Very good.
Then you get the divided as x to the power 2.
Very good. That is the
quotient.
The first term in the quotient. That is the
Yes,
first term in the quotient. Yeah,
Yes,
next.
now you're going to multiply with x to the power 2 with the x to the power 2 minus 1.
Very good. So what will you get?
X to the power 4 and minus x to the power 2.
Minus x squared. Where should I write minus x squared? Under the x squared term.
Yes, ma'am.
It's okay, I can write here. See, I can write it here also, but I cannot simplify x cube and x squared. So I have to simplify with this. So I'll just write it under that, that's all. Minus x squared it is, it's minus x squared. So I'm just writing it under the x squared term. There is no harm if you write it here also, you cannot simplify with x cube. So you will be simplifying it with the 9x squared term. Yeah, now.
Change the signs, ma'am.
Very good.
X to the power 5, x to the power 4 will get cancelled. And will be minus 7, 3 x to the power 3.
Comes down.
Yes, ma'am.
Comes down. Yeah.
Plus
Because
10x.
we have not used this. We have not used this, so that will come down.
Plus 10x square.
Plus 10x squared. Very good. Then the remaining terms.
It comes down now.
Yeah, you can bring all the terms down. Plus 7x minus 10.
Now we got to divide the first term with x to the power 2.
What is this one called? What is this called?
Remind.
The new dividend.
Yes, ma'am, dividend.
New dividend. Yeah, divide.
First number in dividend with x to the power 2.
Yeah,
minus 7.
Term. The first term of the new dividend by the divisor. The first term of the divisor.
Yes, ma'am. Minus 7x.
Very good. That is the second
Quotient.
term of the quotient. That's the second term of the quotient.
Yes,
Yeah.
ma'am. Now we multiply it with the divisor and get minus 7x cubed and plus 7x. Change the signs.
Yeah. Then
7x and 7x is cancelled. The remaining terms come down.
Cancelled. Yeah, this also gets cancelled because 7x minus 7x 0.
Yes, ma'am.
This also gets cancelled. So the remaining terms 10x squared minus 10.
We got to divide the divisor with the dividend again. 10x.
10x squared by x squared.
Yes, ma'am.
So it's 10.
10.
So plus 10.
Yeah. Now we got to multiply the new quotient with the divisor and get the answer 10x squared minus 10. Answer 0.
Change the signs. Very good.
0.
Thank you, Prajakta.
Yes, ma'am.
Done, children?
Completed, ma'am.
Done, ma'am.
Again, here we have to be careful. Told you many times that you cannot multiply this minus and minus straight away like that. You should not multiply. You must first cube it. -1 the whole cubed is -1. You can see it here. -1 the whole cubed is -1. And then -7 into -1 is +7. Here also -1 the whole square is +1. -1 the whole square is +1. And then 9 into 1, 9. Yeah. Give an example of, give one example each for the following. Give one example each for the following. A polynomial of degree 2 in one variable. A polynomial of degree 2. Yes, children? Is this a polynomial of degree 2?
No, ma'am.
Because when you take it up to the numerator, it is x to the power
Power
minus
-2. Yes, ma'am.
It's not a polynomial at all, because an expression is a polynomial only when the powers of the variables are whole numbers. Very simple to remember.
Yes,
An
ma'am.
expression is a polynomial. An expression is a polynomial only if the powers of the variables involved, x, y, z, the powers of x, y, z are all whole numbers. Very easy. What are whole numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. If it's not a whole number, it's not a polynomial. So when it is 1 by, supposing x square plus 5x, supposing we have 1 by x square minus 5x plus 6. This is not quadratic, because when you bring this up to the numerator, it will be x square minus 5x plus 6, the whole power -1, negative. So this one is not a quadratic poly. This one is not a polynomial. This one is not a polynomial. This one is an algebraic expression. It's not a polynomial. But if you had x square minus 5x plus 6 like this one is a polynomial of degree 2. X square minus 5x plus 6 is a polynomial of degree 2. Similarly, x square, say like plus 7. This is also a polynomial of degree 2. But 1 by x square plus 7 is an algebraic expression. It's not a polynomial. Yeah. Next one, a monomial of degree 0. Okay, this also is an example. Simply 10x square minus 10x square minus 5 by 4x square. All these are examples of quadratic. Degree 2 meaning a quadratic polynomial. Degree 2 meaning a quadratic polynomial. Any number of terms. It can have 1 term, 2 terms, 3 terms. Polynomial. They have not mentioned the number of terms. So it can have 1, 2, 3, 4, 5, any number of terms, but the degree should be 2. The degree should be 2. So you can just write minus, see, root 7x square is a polynomial, because the coefficient, what the coefficient is does not affect the degree of the polynomial. Degree is only the power, not the coefficient. So root 7x square. Not roots, not like this, not like this. Root 7x square is a polynomial. Root 7x square is a polynomial. And it is a polynomial of degree 2. Now root 7x square minus 5x is also a polynomial of degree 2. root 7x squared minus 5x plus 9 is also a polynomial of degree 2. So then
Yes,
a
ma'am.
monomial of, yeah, very good. A monomial of degree 0.
Any number,
Correct.
any constant number,
Any
constant number.
constant. Degree 0 meaning
X to the power
constant.
0 and there's no variable.
Constant. Very good. Very confident answer from Project. Very good. So any constant meaning this one? 0? What's the degree then? What is the
0.
degree of-
That's a variable 0.
Yeah, the degree is not defined. The degree is not defined. We cannot give 0 as an example for a polynomial of degree 0.
Yes,
Because 0. Now, if you ask what is the degree of 0, I told you each of you can give a different answer. Now, one will take 0 as 0x squared, and you will say the degree is 2. Because anything with 0 is 0 only. You can write 0 in many ways. You can write 0 as 0y to the power 3, because anyway that is 0 only. 0y cubed is also 0. 0 z to the power 10 is 0. You can write 0 in so many ways. So like this, if you write, each of us can give a different degree for 0. One will say 3, one will say 10. Somebody will write 0a to the power 100 and say the degree is 100. So that means you cannot get one answer from all of you, a unique answer. That means the degree of 0 is not defined. The degree of 0 is not defined because there is no one answer for that.
Yes, ma'am.
Yeah. So 0 is not an example. Any constant other than 0. Okay. A trinomial of degree 12. Give an example of a trinomial of degree 12.
X to the power 12 plus 6 plus 7.
Plus
6 plus 7. 6y plus 7.
6y plus 7. Or maybe 6x plus 7. Very good. X to the power 12 plus 6x. Anything plus 7. Is a trinomial of degree 12. Is a trinomial of degree 12. Is this a trinomial of degree 12?
Yes, ma'am.
Yes, ma'am.
This one is a trinomial of degree 12. This one is a trinomial, x to the power 12 plus x to the power 11. They're all unlike terms. Don't think you can add them. X to the power 12 plus x to the power 11 plus x to the power 10 is a trinomial because you can see 3 terms.
Yes, ma'am.
And you cannot simplify any of them. See, if you cannot write 5x to the power 12 plus 4x to the power 12 minus 6x to the power 12 and say this is a trinomial of degree 12 because you can simplify. What happens when you simplify? 5x to the power 12 plus 4x to the power 12 is 9x to the power 12 and 9x to the power 12 minus 6x to the power 12 is 3x to the power 12. This one is a polynomial of degree 12, but it's not a trinomial. It's a monomial of degree 12. So you can, when you write 3 terms, you must see to that they are not like terms and they cannot be simplified further. So this one, this example, x to the power 12 plus x to the power 11 plus x to the power 10, you cannot simplify them. You cannot simplify them further. So it is a trinomial. And it is of degree 12 because the power is 10 here, 11 here, 12 here. So the highest power is 12. So the degree is 12. This one is an example of a trinomial of degree 12. 3 distinct terms we have and the highest power is 12. So the degree is 12. This one looks like a trinomial of degree 12. Looks like that. But you can simplify. On simplification, this is the result. So what do you conclude? This is a monomial because only one term. It's a monomial of degree 12. Degree 12, but there are 2 conditions. Not one condition. There are 2 conditions. It should be a trinomial and the degree should be 12. But this example satisfies only one condition. degree 12, but does not satisfy the other condition that it should be a trinomial. Only one condition is satisfied.
Yes, ma'am.
So be careful when you give an example. Make sure that, even after simplification, don't give an example where simplification is possible. Give an example in the simplified form. Okay, so I hope that was useful for all of you. So you can give your examples, children. You just take down the question. Take down the questions. You can give your examples. Just wait for 30 seconds. Yeah. So I've just given some examples here. You can take a picture if you want. This is a polynomial of degree 2. This one is a polynomial of degree 2. When we say polynomial, it can be a monomial, binomial, trinomial, anything. Polynomial meaning any number of terms. It can be a monomial, binomial, trinomial, anything. This one is a monomial. And the degree is 2 because this is one term. There are two variables, x, y. So we should find the sum of the powers. 1 plus 1, 2. So degree is 2. This one is quadratic in two variables, x and y. This one is a monomial. Let's do it one by one. This one is a monomial because there's only one term. The degree is 2 because 1 plus 1, there's only one term. So we should find the sum of the powers of the variables. 1 plus 1, 2. So degree is 2. And there are two variables, x and y. So it's a monomial of degree 2 in two variables, x and y. You can give in one variable also, minus 55 z square, degree 2. Answer these questions. Now, children, what I'm going to do is I'll share the. Now, what happens is, somebody or the other keeps missing the classes. So we hardly have all of them in the session. I'll share the playlist links of, all the whatever chapters. What have we covered? Linear? No, what have we done? Number systems and polynomials we're doing. So I'll share the playlist links. Now, every time I add a video, I don't have to share the recording every time with you. See, now, right now for your standard, I have only two playlist links. One of number systems, the other of polynomials. That's all. I'll share both the playlist links with you. So you'll get two links. One link will be of number systems. The other link will be of polynomials. Now, supposing you miss a class, you don't have to ask me for the recording because every time I update the playlist. Now, supposing the playlist today has 10 videos in polynomials. Now, after this class, so after I finish this class, I'll download this meeting recording and I'll add it to the playlist. So there'll be 11 videos. It'll be updated automatically. Same link, you'll have 11 videos. So like that, if we have some 20 sessions in polynomials, the same link you can use. It's a playlist link. So every time I add the videos in it, the playlist link will get updated. So you don't have to request for the meeting recording at all. You don't have to request for the meeting recording. Two links, two playlist links, one for number systems, one for polynomials. Save that with you, have that with you. So now when I upload today's meeting recording in the playlist, you will get it. Now it's not there. Supposing I share the playlist link now it's not there. The meeting today's recording is not there in it. But once I update the playlist, that will be added. And same link you can use to view that video. So you don't have to request for the meeting recordings in case you miss any session. Save these two playlist links, that's all. Yes, what's the answer for the first one? The polynomial has dash terms. So it is a dash. Yes, quickly.
One term.
The polynomial is one term.
One
One term. So it is a
monomial.
Monomial. Because it has only one term. Based on the number of terms, it's called a monomial. Then the
Yes, ma'am.
degree of the polynomial is
4.
4.
4. So it is a
Biquadratic polynomial.
biquadratic polynomial.
Biquadratic.
Based on the degree, it's a biquadratic polynomial. The degree is 4, so it's a biquadratic polynomial. See, based on the degree, it's a biquadratic polynomial. Based on the number of terms, it's a monomial. The numerical coefficient of C is
Not different.
1.
From root 5 by 8.
root 5 by 8. Root 5 by 8. The numerical coefficient of C is root 5 by 8. The literal coefficient of C is
B.
the literal coefficient of C is 1. No. Literal means a letter. Numerical means number. Numerical means of a number. Literal means letter.
B. Letter B.
Okay, I can hear B from Pradit. Yes. Other answers? The literal coefficient of C is
1.
A and B.
A and B.
No.
A, B, D, ma'am.
Very good. A, B, D is the right answer because you can write root 5 by 8 as, I'm sorry, you can write this term as A, B, D, C also. Now, what happens is, no, when we say coefficient, we are only looking for something before it. Correct, before it. But
Yes,
when
ma'am.
you're asked, yeah, see, it can be like this also. No, it's the same thing. See here. Root 5 by 8, A, B, D, C. Now, what is before C? A, B, and D. So, A, B, D. A, B, D, all the letters. So that means, 1 minute, I'll tell you. Now for C, if you're asked the literal, okay, numerical coefficient, this is the number. For all, this is only the numerical coefficient for A, B, C, and D. Or for A, B, C, D. Because this is the only number. This is only the numerical coefficient for anything. Literal coefficient meaning letter. The literal coefficient meaning letter, not the number, only letter. For C means take away C. All the others, A, B, D. All the others other than C. All the others other than C. So if you are like finding it difficult to believe, how is that possible? This is the explanation. You can write this as root 5 by 8, A, B, D, C also. Because we are kind of used to looking for something before it. Coefficient means whatever is before it, something like that we have understood. So yeah, whatever is before, what the letters before C, A, B, and D. Is it convincing?
Yes, ma'am.
Yes, ma'am.
So it's A, B, D. A, B, D.
Yes, ma'am.
Yeah, right on. Don't write only the answer in the blanks, children. Please write. You don't have to write it 2 times. Write the question and then the answer. You can write the answer alone. This one alone. Write this alone with the dash. Done, children?
Yes, ma'am.
Yes, ma'am.
How many of you are not writing and just taking screenshots? Raise your hand. How many of you are not writing now during the session and only taking screenshots? Raise your hand. Can I believe this? All of you are writing?
Yes, ma'am.
Yes, ma'am.
All right. All right. So many of us, don't communicate in the class. Sorry. Srijana, no. Arjun, no. Students who do not communicate with me, who do not interact with me, Arjun, Srijana, Lishant, Rishmi. Arjun, Srijana, Rishmi. Please interact. Say yes, no. If you understood, say yes. Did not understand, ask your doubts. Please participate. Done, children, this one?
Yes, ma'am. Yes, ma'am.
All right. All right. Yeah, this is homework. Complete this 1 minute. Take a screenshot. Yeah.
Yes, ma'am.
Yeah, take a screenshot, children. Please complete this.
Taken, ma'am.
Yeah, good. Yeah, let's start working from behind. Work 6A, children. 6A. Let's start with 6A.
Yes, ma'am.
Please write the question. Very important question. Very, very important question. Done, children?
Done, ma'am.
So if P of X, you can see a biquadratic polynomial for P of X is divisible by G of X. G of X is a quadratic polynomial. So if P of X is divisible by G of X, find A and B. Now G of X is a quadratic polynomial. You can factorize it by splitting the middle term and find the two linear factors. Now, supposing when you factorize and the linear factors, I'm just telling for example, okay? So something like x minus 4 and x plus 3. Now, for example, 72, okay, is divisible by 12, right?
Yes, ma'am. 6.
72 is divisible by 12. Now, 4 and 3 are the factors of 12.
Yes, ma'am.
So 72 is divisible by 4 and 72 is divisible by 3.
Yes, ma'am.
If 72 is divisible by 12, 72 will, and 12 is 4 into 3, 72 will also be divisible by 4 and 3. Now, for example, 9. Okay, now 9 tables, what do we get? What do you get? 9 2s are 18, let's say. So 18, 72 itself. So,
Yes, ma'am.
for example, 72 divided by 18. And 18 is 9 2s are 18. So 72 is divisible by 18. And 9 2s are 18. That means 72 is divisible by 9 and 72 is divisible by 2. It's true, I'm saying. It is true.
Yes, ma'am.
100 is divisible by 20. And 5 4s are is 20. 5 4s are 20. That means 100 is divisible by 5 and 100 is divisible by 4. If since 100 is divisible by 20 and 20 is 5 into 4, 100 is also divisible by 5 and 100 is also divisible by 5 and 4. Okay, 10 2s are 20, whatever you want to say. 10 2s are 20. 100 is divisible by 10 and 100 is divisible by 2. Similarly, please listen to me, children, don't start working. Similarly, we find this is a quadratic factor. This is a quadratic factor. There's some work going on here and there's a lot of noise. I'm not able to concentrate. So this one is a quadratic factor. You can factorize this and find the two linear factors. So I was telling, for example, x plus 4 and x minus 3 are the two linear factors, like how you, break down 20 as 5 into 4. Similarly, we break down this quadratic polynomial into its linear factors, say x plus 4 and x minus 3. So since p of x is divisible by g of x, and g of x is nothing but x plus 4 into x plus x minus 3, p of x is divisible by x plus 4 and p of x is divisible by x minus 3. I repeat, supposing the factors of this one are x plus 4 and x minus 3. How we'll get this? By splitting the middle term, we'll find the two linear factors. Since p of x is exactly divisible by, divisible means exactly divisible. Divisible itself means exactly divisible. Since p of x is divisible by g of x, and these are the factors of g of x, it means p of x is divisible by x plus 4 and p of x is also divisible by x minus 3. That's the first step. Breaking down this expression into its linear factors. Now you have two linear factors. Now, if x plus 4 is a factor, x plus 4 is equal to 0, x is equal to minus 4. So that means p of minus 4 is equal to 0 because factor p of minus 4 is equal to 0 is one condition. If you get a condition, it's easy. You can work with that condition and get an equation. And supposing the other factor is x minus 3. X minus 3 is a factor. So when you equate it to 0, you get x is equal to 3. That means p of 3 is 0. P of 3 gives a remainder 0. Why 0? Because factor. So like this, we get two conditions. So when you work these conditions, you can find the values of a and b. That's the procedure. You can find the values of a and b. So what is step 1? To break down the divisor. To split the middle term of the divisor and find the two linear factors. After you find the linear factors, p of x will be divisible by each of them. P of x will be divisible by each of the linear factors. So equate the linear factors to 0. So you get x is equal to 3. Since this is called p of x, it's called p of x. So p of 3 will be 0. P of 4 minus 4 also will be 0. So we got two conditions. When you work with these conditions, you can find the values of a and b. Once you get the values of a and b, supposing you get a is 2 and say b is 3. So you can construct p of x. A is 2, so 2x cubed, and b is 3, so plus 3. So now you've constructed the polynomial p of x. Earlier you did not know the coefficient of x cubed and the constant b. In the question, we do not know the coefficient of x cubed. That's why it's called a. And we do not know the constant. That's why it's called b. In the question, we do not know the coefficient of x cubed, a, and the constant b. Now, after using the conditions and solving, we find the values of a and b. So now you can construct the polynomial. Supposing this is 2. So 2x cubed. And supposing this is 3 plus 3. So now we have the polynomial completely. Polynomial. We have the polynomial now. Now the question is, hence find a and b. We found a and b. Hence factorize p of x completely. Hence factorize p of x completely. Now p of x is a biquadratic polynomial. And to factorize it completely, we know that we have to do the long division method. To do the long division method, we need two factors. We already have them. See here, we have a quadratic factor. It's given in the question itself. We already have, see, normally we have to find one linear factor, another linear factor, multiply these two factors, then find the quadratic factor. Now you don't have to do all that because in the question itself, we have the quadratic factor x squared plus 5x plus 6. See, this one is divisible by this. So in the question itself, we have the quadratic factor. So directly do the long division. Directly do the long division. In the quotient, you will get the other factor. Split the middle term and find all the four factors. I'll show you the answer slide. Yeah. Please go through first. The answer is also in the second. The answer continues in the next slide. Doesn't end here. Please go through the answer. Okay, let me do it quickly so see here, g of x. I've taken up g of x, splitting the middle term and found the two factors. Since p of x is divisible by g of x, p of x is divisible by x plus 2. X plus 2. P of x is divisible by g of x. So p of x will also be divisible by x plus 2. When p of x is divided by x plus 2, the remainder will be 0. The remainder will be 0. So that means p of minus 2 is 0. Similarly, p of minus 3 is 0. When you do this, you're getting two equations. You get two equations. And when you solve the two equations, you can get the values of a and b. So we got the values of a and b. We get the values of a and b. And now you can construct the polynomial. In place of a, use 2, and in place of b, use 12. And then to factorize the polynomial completely, this is the biquadratic polynomial. And this is the quadratic polynomial given to you in the question, the quadratic factor. So perform the long division and then see here using the division algorithm. Dividend is equal to divisor into quotient. Plus remainder is not shown because it's plus 0. And then this one you don't have to show the steps because we know x plus 2 into x plus 3 because we know it here. See here, we know that we factorized this. We already factorized this and we got x plus 2 into x plus 3. So here directly you can write. You don't have to show the steps. You can directly write this one as x plus 2 into x plus 3. We already factorized it earlier. See here. We've already factorized here. We've shown the steps and we got x plus 2 and x plus 3. So you can write it straight away. But here this is new. This one is new. So split the middle term. Split the middle term, grouping and find all the factors. Yeah, start working, children. I'll just come back. Run, children, this slide.
Yes, ma'am.
Yes, ma'am.
Yeah. So now we solve the two equations, 1 and 2. Write the equations one below the other. You'll have to change the signs. That is, this minus becomes plus, this becomes minus, and this becomes plus. Because only if you change the signs, plus b and minus b can get cancelled. And you can find the value of a. Only when you change the signs, plus b minus b will get cancelled. 0. And you can find the value of a. You have to eliminate one of the variables. You have to eliminate one of the two variables. You'll have to cancel out one of the two variables. So that can happen only when you change the signs. So you're subtracting equation 1 minus equation 2 you're doing. Now minus 8a plus 27a is 19a. Is 19a. Minus 8a plus 27a is 19a. And this minus 4 plus 42 is 38 plus 38. 19a is equal to 38. A is equal to 38 by 19. A is equal to 2. Now to get the value of b, substitute. Substitute a is equal to 2 in any one equation. You can substitute in this equation or in this equation. In both the equations, you can get only b is 12. You cannot get a different value. Any equation, you can substitute the value of a in equation 1 or in equation 2. So see, in equation 1, in place of a, I've used 2 minus 8. A is 2 plus b is equal to minus 4. So minus 8 into 2 is minus 16 plus b is equal to minus 4 and b is equal to 12. So we found the values of a and b. Now construct the polynomial. In place of a, 2 and 12, no, a is 2. So this is 2 and b is 12. So this is 12. This is the polynomial now. This is the polynomial. Now the division process, divide the polynomial by the divisor given. This one is exactly divisible. This one is exactly divisible by x squared plus 5x plus 6. And please recall that to factorize a biquadratic polynomial, you need a quadratic factor. Remember, we used to find one factor, another factor, and multiply the two factors to get the quadratic factor. That's how we factorize that's how we factorize a biquadratic polynomial. We find one linear factor, another linear factor, and we multiply the two linear factors to get the quadratic factor. So here the quadratic factor is given to you straight away. So why find? You already have a quadratic factor. So directly do the division. So those steps you can save. Finding one linear factor, another linear factor, and multiplying the two linear factors. Those steps you can save because you directly have one quadratic factor. So do the division. Do the division. Yeah. And then use a division algorithm. Yes, finish it. Now it's left to you to ask me your doubts. Please finish and let me know, children.
Completed, ma'am.
Completed.
Completed, ma'am.
Okay. So in this question, we're doing two things. We are finding the values of A and B, and we are also factorizing the biquadratic polynomial. So it's like two questions in one. We normally have find the values of A and B, or we have to factorize a biquadratic polynomial. Here it's like two questions are merged into one. We have to find the values of A and B and also factorize the biquadratic polynomial. So all that you need to remember is to factorize a biquadratic polynomial, you need a quadratic divisor. Quadratic divisor that is already given to us. So we straight away perform the long division, use the division algorithm. Dividend is equal to divisor into quotient plus remainder. Then we find the factors. Is it okay, all of you?
Yes, ma'am.
Netra, do you understand?
Yes, ma'am.
Tanishka, long division is comfortable for you now, Tanishka? I can't hear you. No, I can't hear you. Okay, just raise your hand if you understand. Tanishka. Okay, fine. Right, so. No problem, Kanishka, you can text me later. Yeah, so that's about this question. And the next one, the polynomials, I think we don't have time to finish the answer in the class. I'll just show you the answer slide. We'll understand the procedure. I'll show you the answer slide, take a screenshot and complete it. The polynomials P of X is equal to, okay, interested children can complete this. We can, I've already given, that is a simple paper, one which you took a screenshot earlier. No, that's a very simple paper. You don't need a long time to complete that. So I think you can finish this also. 1 to 5. Questions 1 to 5. Yeah. We'll discuss on Saturday. Take a picture, children. Yeah. Questions 1 to 5. And the earlier picture which you've taken. Complete these two. We'll see the answers on Saturday. You must remind me, children. See, if I forget, you should remind me that we have to discuss the answers. Yeah. The polynomials P of X and Q of X, whatever is given there, when divided by G of X, X minus 2, leave remainders R1 and R2 respectively. That means when you divide P of X by G of X, the remainder is R1. And when you divide Q of X by G of X, the remainder is R2. When you divide, it's here. When you divide P of X by G of X, the remainder is R1. And when you divide Q of X by the same thing, G of X, there's only one divisor two dividends, two different dividends, the remainder is R2. See, there are two dividends. P of x is one dividend. Q of x is the other dividend. There are two different dividends. P of x and Q of x, two different dividends, but only one divisor, G of x. G of x is the only divisor for both. So P of x is divided by G of x. Q of x is also divided by G of x. P of x divided by G of x. Q of x also divided by G of x. Remainder R1, remainder R2. That means G of x is not a factor of P of x or Q of x. The remainders are R1 and R2 respectively. Now, with this information, you need to find the value of K if the condition R1 minus R2 is equal to 0 is given to you. Find K if R1 minus R2 is equal to 0. Again, an important question. So see here, case 1. This is important to write. R1 is the remainder. This shows your understanding. R1 is the remainder when P of x is divided by G of x. R2 is the remainder when Q of x is divided by G of x. Both are divided by G of x only. Here the dividend is P of x. Here it is Q of x. Both are divided by G of x. Remainder is R1. Remainder is R2. That means what? What is G of x? X minus 2. X minus 2 is equal to 0. X is equal to 2. P of 2, because this is P of x. P of x. So you must say P of 2 is equal to the remainder R1. Do you understand the condition? P of 2 is equal to the remainder R1. Yes or no, children?
Yes, ma'am.
Okay. But writing this one is important. Once you write that, you know how to proceed. Because how do you express P of 2 in P of x? Wherever there is x, you should use 2 is equal to R1. So you get an expression for R1. Now again here, G of x, x minus 2 is equal to 0. X is the divisor is x minus 2, right? Equate the divisor to 0. Always we equate the divisor to 0. The linear divisor to 0. X is equal to 2. X is equal to 2. Now the dividend is Q of x. So you must say Q of 2, not P of 2. The dividend is Q of x. So Q of 2 is equal to the remainder R2. So in Q of x, wherever there is x, you should use 2 is equal to R2, is equal to R2. And you will find R2. Now use the given condition. R1 minus R2 is equal to 0. Write the condition. R1 minus R2 is equal to 0. Now substitute for R1. R1 is 4k plus 15. And what is R2? Here, 14 plus k. 14 plus k. Since it's minus, put them in a bracket because the signs will change. Put a bracket. This is R1 in bracket, R2 in bracket, minus in the middle. So it will become minus 14 minus k is equal to 0. Solve and find the value of k. That's the question. Find k. K, the value of k is minus 1 by 3. Take a screenshot. Complete this now after the class, children. Take a picture.
Taken, ma'am.
Yeah. All right, children. So that's it. Anybody still to take the screenshot? I'll wait for some time. Take a picture. Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you. Thank you.
Thank you, ma'am.
Thank you, children.